In this video, we're going to look at models of the atom, especially about electrons, and their limitations. So in this atom, I have a lithium atom. There are two electrons in the 1s level and one electron in the 2s level. So the question is the 2s electron in lithium over here always further from the nucleus than the 1s electrons in lithium? In other words, do these electrons orbit the nucleus much like planets would orbit the sun, or is that motion more random and more complex? So I think we got to go to an example to explain that. And I'm going to grab a couple tools here. And I'm going to go to an analogy. Instead of electrons, I'm going to think about bees. And if you don't know what this is a bee's nest. Okay, I know it might be kind of hard to tell that, but that's a crude drawing of a bee's nest. And I'm going to get a different marker here, and I'm going to talk about a low energy bee. What's going to buzz around randomly, and it's probably not going to want to get too far from the nest because it doesn't have a lot of energy. Okay, so that is the low energy bee buzzing around the nest, not going too far because maybe it's afraid it won't get back. It doesn't have a lot of energy right there. It didn't eat its honey nut Cheerios, I guess, that day. Now I'm going to go to a higher energy bee, and we'll have that one be green. Now this one has more energy, so when it buzzes around the nest, okay, it's buzzing around the nest. It's not afraid to go farther than the low energy bee because it has more energy. Okay, so what we have here now is we kind of got an overlay of the nest, and the one energy bee is in red, and the low energy bee is in red, and the high energy bee is in green. Notice that on average, the high energy bee is further from the nest than the low energy bee. But at any one point in time, the lower energy bee might be closer to the nest than the higher energy bee. This is the same story with the 1s and the 2s electron. Okay, the 1s electron is like the low energy bee. Its motion is a lot more random than a fixed orbit. It's zipping around with less energy, but it'll tend to be closer to the nucleus than the 2s electron, which is buzzing around in a spherical, generally what comes out is a spherical shape, but with more energy and on average further from the nucleus. So it's real important to see that if you look at these electrons, the motion is more random. And if you think about these electrons as actual movement, it's not an accurate portrayal. The motion is much more random. If you think about these shells or rings in terms of energy, then it is accurate. The 2s electron has more energy than the 1s electron. And on average, the 2s electron will be further from the nucleus than the 1s electron. So if you think about shells and rings as energy or average location, that's a good assumption. If you think about it in terms of actual location, it's not. Okay, let's just go to one other thing you might see, and that's called the electron cloud. So this is a 1s electron, and it's kind of like getting a snapshot of where an electron could be. Notice it does take a spherical pattern, but it tends to have, there's no defined boundary, but it gets less and less likely the further you get away. A 2s electron, again, taking the same shape, but the chances of finding it further from the nucleus are greater than the 1s electron. Again, I could overlay the 2s on the 1s. I didn't really know how to do that, so I kind of spread that out right here just to show that. But it's a similar type of thinking as what we have here. Notice these distribution of where an electron might be is almost looks like a cloud. That's why you get that description of an electron cloud. It's really just a distribution of where you're likely to find an electron inside of an atom. So going back to what we started with, is the 2s electron in the lithium atom always further from the nucleus than the 1s electron? No. The shells do not mean actual location. It does not mean orbit of the 1s electron going around here in a fixed orbit, the 2s electron going around here in a fixed orbit. But the shells or rings do mean energy. So the 2s electron always has more energy than the 1s electron. And it does work if you want to think about that in average location. The 2s electron on average will be further from the nucleus than the 1s electron. All right, hope that clears up how we're using these models, some of their limitations, and give you a better understanding of that. Thank you.